Hi, I'm just going to run through the questions that have been set on the mixed revision for level 4 block 3. Okay guys, so this is probably slightly harder than what you would have had in your test if you're in school, because while I was trying to give you a revision, it's slightly harder just to try and get you up to speed for your tests. Okay, so let's have a look at number 1, so the fraction questions. So 7 2/5 subtract 3 1/8. So as we know, we cannot subtract fractions until we have a common denominator. We need the same number on the bottom. So what we are going to do, we're going to multiply top and bottom in each fraction so that we have a common denominator, the same number on the bottom of each fraction. So the smallest number that 5 and 8 both divide into is 40. So I'm going to multiply top and bottom here by 8 and top and bottom in the second fraction here by 5. And then 7 subtract 3 is 4, and 16/40 subtract 5/40 is 11/40. So 4 and 11/40. Right, question B, 3.5 multiplied by 5/14. So if we've done all the practice on multiplying fractions that was given not so long ago, we will know that we need to change 3.5 into a top-heavy fraction. So 1 whole is 2 halves. So 2 wholes would be 4 halves, 3 wholes would be 6 halves, add the other half would be 7 halves. Then once we have it in this format, it is literally top times top, or numerator multiplied by numerator, and bottom times bottom, or denominator multiplied by denominator, which leaves 35/28. Now those numbers are both in the 7 times table, which hopefully you guys have spotted, so we need to divide top and bottom by 7. Which will give us 5/4, or as a mixed number, 1 whole and 1/4. Dividing fractions. So to divide a fraction, we need to flip the divisor, the second number, upside down, or we need to invert it, I suppose I should be saying, if I'm using the correct mathematical language. So rather than dividing by 13/9 here, I'll be multiplying by 9/13. So let's go back to the start of the question. So 1 whole is 6/6. So 2 wholes would be 12/6. Add another sixth, 13/6. 1 whole is 9/9. Add another 4/9 is 13/9. So as I was saying a minute ago, if I'm dividing by 13/9, I would have flipped that upside down and multiply by 9/13. Now here, what have I got? I've got 9/13 divided by 6/13. So I could do 9 times 13, 6 times 13, and cancel or simplify. But what we could be saying is, well, hang on, I've got 9 somethings divided by 6 somethings. So I'm just going to get 9/6 when I do that. So if you don't like that idea, guys, just, well, what we could do, let's just write on there. So I've just made that into one fraction, so I've got 13 9s over 6 13s. So what we can do, we can cancel or simplify those two, because 13 divided by 13 is just 1, so I'm just going to be left with 9/6. If not, if you don't like that, do 9/13s, which is 117, 6/13s, which is 78, and that will simplify down to 9/6 once you've done that by dividing top and bottom by 13. Okay, so 9/6, divide top and bottom by 3 is 3 halves, which is 1 whole and 1 half. Okay, so that is the fraction questions. Question 2. So we've got the equations. So what do we need to do here? We're trying to get x terms onto one side and number terms onto the other side. Okay, so what we're going to do here, so this is like having a seesaw or a balance. We're going to pick this 3x up, or we're going to take it off the seesaw, or we're going to subtract 3x from the right hand side of the equation. Now, just like if you guys were on a seesaw with a lot of mates and you're perfectly balanced, if one of you got off, it would no longer be balanced and one end would be heavier than the other, so it wouldn't be equal anymore. Okay, so if I subtract 3x from one side of the equal sign, or from one side of the seesaw, then I need to subtract 3x from the other side of the equal sign. Okay, so 3x minus 3x is 0, so I'm just left with 19 there. So I just want numbers on this side. I don't want any x terms. 7x minus 3x is 4x. I've still got this minus 1, of course. The next step, I would just like 4x here. So at the moment, I'm subtracting 1 from it. So if I add 1 on, if I'm doing minus 1 plus 1, I get 0. So I need to add 1 to the other side, so I'd have 4x equals 20. And then divide both sides by 4, x would be 5. So part B, probably slightly easier than part A, I think, as long as we know to multiply out the bracket first. So 3 times 2x, 3 times 1, so 6x plus 3 equals 27. I'm then going to subtract 3 from both sides. Just thinking about the seesaw method we're talking about above there, if I subtract 3 from this side of the equal sign, to keep it balanced up, I must subtract 3 from the other side. Why am I subtracting 3? Because I would just like to have 6x on the left-hand side here. Okay, so if I subtract 3, I'll be left with just the 6x. And then 6x equals 24. Divide both sides by 6, we will get x equals 4. So part C is combining part A and part B, really. So I need to multiply out both brackets. So 2 times x, 2 times minus 5, 3 times x, 3 times plus 8. And then what I really like to do is keep my x terms positive if I can, okay? So I know on the previous 2 questions we had the x terms on the left. They could be on the right. It doesn't really matter. So here, if I do 2x minus 2x, I'll get 0x terms here. And 3x minus 2x is x. Okay, so that is scribbled out there. That just says x. I could have taken 3x from both sides. That would be fine. But I would have had minus x minus 10. I just prefer a positive value of x. Okay, now remember this minus sign belongs to the 10, so it is minus 10. So I want this x on its own. At the moment I'm adding 24 to it, so I need to subtract 24 from both sides. So we'd end up with x equals negative 34. Now, question 3 is an inequality. This works exactly the same way as an equation. Okay, we're going to do exactly the same thing we've done in question 2, exactly the same method, except we're going to keep this greater than sign each time. So we're not finding a value of x which will make it equal the other side, we're finding all the possible values of x which will keep it larger than the right hand side. Okay. Essentially we're doing exactly the same method as before. So I'm going to get x terms onto one side, number terms onto the other. So here I'm going to subtract 2x from both sides of the greater than sign, which leaves me with just minus 5 here. I'm then going to add 2 to both sides, which leaves me with just 3x is greater than minus 3, and divide both sides by 3, x is greater than minus 1. Okay, so a possible answer for that question could be 0, 1, 2, 3, 4, 5, 6, 7, anything greater than minus 1. Could be negative 0.9. That would work as well. But this describes every single value because it's saying any value that is greater than minus 1. Question 4, Stardix. I don't think I told you guys to have a go at it in the assignment, or I might have said have a go, but it is quite tricky. So I'll just get it on the screen here. So question 4 on the screen. Part A, form an equation for the area of this rectangle. Well, how do you find the area of a rectangle? That is length times breadth. Form an expression. What that is telling us is that there's going to be an x in the answer. So we're not going to get a nice answer like 27 centimeters squared or 15 centimeters squared. We might get something like 5x plus 3 or 27x minus 15. Okay. But we'll find an area of a rectangle by doing length times breadth. So we know the length, we know the breadth, so I'm just going to multiply those two together. Okay, so area is L times B, which is 5x minus 6, all multiplied by 2, so we could put the 2 at the front of the bracket there, because we're used to doing that. But basically, 2 times 5x, 2 times minus 6, so the area would be 10x minus 12 centimeters squared. Okay. Part B, a second rectangle is drawn with an area which is equal to the first rectangle. Okay, so what's the area of this rectangle? Well, again, we're going to have to do length times breadth. So x plus 2 multiplied by 6. So x times 6, 2 times 6, that'll be 6x plus 12 centimetres squared. Again, guys, if you're a little bit lost on this one, that's fine. It is a trickier question. You can ask about it when we go back to school. Oh, just trying to get the question back up. I'm having trouble with the... Sorry about that. So find a value for x, find the area of the shape. So we know that the two rectangles from part A and B have the same area, so we can say 10x minus 12 equals 6x plus 12. Okay. Now again, we've not done many questions like that in class, so I'm not expecting you to be able to do it, but normally we'd be doing this in class. We could be asking, I could be going through similar questions on the board. Okay, so once we've got to this point, it's essentially the same as question 2 and question 3 method-wise. So we'd subtract 6x from both sides, then add 12 to both sides, and then we'll end up with 4x equals 24. Divide by 4, we get x equals 6. So that is a value for x. Part 2 says find the area of the shape. Well, looking at that, the area is given by 6 times x plus 2. We've just worked out that the value of x is 6. So the length there, instead of x plus 2, would be 6 plus 2, which is 8. Okay, so the area would be 6 plus 2, which is 8, times 6, which is 48 centimetres squared. Right, I'm just going to go over number 5, and I'll do a second video for the calculator section. Number 5 is reasonably straightforward compared to number 4, certainly. So number 5, share £360 in the ratio 1 to 2 to 3. So in class, guys, remember we're using a bar model for this. So we've got one part, somebody's getting 2 parts, and another person's getting 3 parts here. So altogether there are 6 parts. So let's work out what each part is worth. So the 6 parts, they're worth 360 in total. So 360 divided by 6 is £60. So this would be £60, this would be £260, and this would be £360. So the ratio would be £60 to £120 to £180. And I will do a second video for the calculator section.